let's use what do we have from last video as an example. Let's get rid of the 2. Okay, so suppose I want to know an antiderivative of this function x times cosine of x squared. Then here I'm gonna notice that, okay, this is a composite function. Okay, and then we have something extra. Okay, so what's gonna happen here is we're gonna take a guess. Okay, because this is just our guess, so it may work and it may not work. So when your guess does not work, just try another one. All right, so with practice, you're gonna see more and more what I mean here. Okay, all right. So so when I see a composite function, I will try to guess the inner function. Okay, and then we hope we can convert the original integral to a easier integral. Okay, so when I say it may work or it may not work, it depends on whether you would in the end up getting an easier integral that you know how to integrate. Okay, if you end up getting something more complicated, then that's it does not work. All right, so here if I try the inner function u to be x squared, all right, like we discussed from before, then I'm gonna do this very important step. So I will differentiate the equation. All right, but I'm gonna write it this way. Okay, so I'll have du equals 2x dx. So in general, what I'm doing is if I have u equals g of x, then the equation I'm writing here, which we call differential equation of differentials, is in this format: du equals g prime of x dx. So you want to make sure you write the du and you write the dx, and whatever you get in from the dx, it depends on the function g. Okay, so if I go back to the example here, this is g of x is equal to x squared, hence g prime of x is equal to 2x. So you can see that the equation I have for my differential is du equals 2x dx. All right, so then we have that. Then what happens here? So what happens is next, we try to convert the given integral. Alright, so the given one is this, x cosine of x squared dx. Alright, so this part I know it's gonna be cosine of u because u is equal to x squared. What's left is x dx. So now I'm trying to see if we can express it in terms of u. Okay, so this is where we use the differential part, du equals g prime of x dx. Okay, so what that means is this guy we have up there. Alright, okay, so in this example, what is the du g prime dx? That is du equals 2x dx. This is what we have in this particular example. All right, so if du equals 2x dx, what does that mean? That means if you divide this equation by 2 like that, then you end up getting x dx is equal to 1/2 du. Why do I want to look at x dx equals how many du's? Because remember, this is what we have in the green. Okay, so now altogether I'm gonna have this is equal to cosine of u times 1/2 du, because like we just explained, the remaining x dx is equal to 1/2 du based on the computation. All right, so now you have 1/2 cosine u du. Ask yourself, is this a easier integral compared to the original one? And I would say yes, because before you have x cosine of x squared, and here you only have a single cosine of u. Okay, so the answer is yes, and it is one of the integral formulas. All right, so then antiderivative cosine u is equal to sine of u. But we're not done yet. So u is something that you created in the middle in order to solve the problem. So you're gonna write u back to x. So convert u back into x. All right. So altogether, this is saying antiderivative of x cosine x squared is equal to 1/2 of x sine x squared plus any constant. Okay, this is the same result as what we had from before. Right? Okay, so this is what we had in the previous example. Now if I divide this by 2, I would have integral of x cosine x squared equals 1/2 sine of x squared plus 1/2 c. But remember, this c is arbitrary. So what I can do is I can just again call this c, abuse the notation, because who cares? This c represents any constant. All right. So you see, in the in the previous video, we kind of like went from, okay, if I happen to have this composite function and I apply the chain rule to take the derivative and I get the result, so then I can see that, oh, if I happen to have an indefinite integral like this, then I know what the answer is. But in our example here, it tells you that when you are given an indefinite integral, and you notice it looks very complicated and involves a composite function. By the way, very complicated meaning it means it's not from one of the integral formulas. Okay, and we notice you have a composite function here, so you're trying to decompose this composite function, and you have an outer function and an inner function. So you're gonna set u to be the inner function. So in this example, we have u equal to x squared. Once you have this guess, so this is what I mean. You have to take a guess. Okay. And once you have this, then you're gonna differentiate the equation, but make sure you keep the du and dx, so then you can do conversion correctly in a second. So now you go back to your given integral and see if you can successfully write everything that's in terms of x into something in terms of u only. Okay, so if you are not able to do such a conversion, meaning you have some x and you have some u, then that's also an indication that tells you should try something else, try a different u. Okay, so if this is a good guess, then the integral that you have in terms of u is going to be something easy. Easy means it's going to be something from the integral formulas. Then you just go ahead, find the antiderivatives and write the u back into x. So here we have, in this example, the answer is 1/2 x squared. 1/2 sine of x squared plus any constant